A sandbag is dropped from a balloon at height of 60 meters when the angle of elevation to the sun is 30 degrees. So we can see that, let's say the sandbag is dropped from here and the sun is going to be somewhere over here. So this angle is 30 degrees as I have labeled, and this height over here is 60 meters. The position of the sandbag is S of t is 60 minus 4.9 t squared. So starting height is 60 and minus 4.9 t squared as you fall down. Find the rate in meters per second at which the shadow of the sandbag is traveling along the ground when the sandbag is at a height of 24 meters. So if the sun is over here, like there, and this is where the shadow is at the start. That's why I've labeled point X, and the sandbag is over here. So as the sandbag falls down like this, the sun's rays will give a shadow over there. So at this position, the sun will give this shadow, and at this position, we're assuming that the angle stays almost the same, so the sun will give this shadow until the sandbag hits here where there is no shadow because it's on the ground. So find the rate in meters per second at which the shadow of the sandbag is traveling along the ground when the sandbag is a height of 24 meters. This over here is 24 meters. So if we draw a triangle like this of 30 degrees, this is the point where the shadow will be at, and we have to find the rate of change of this distance over here. So this distance at the start is some value, and then as it moves here, this distance decreases. So you have to find the rate of change of the distance from this point to this point wherever the shadow is. And this point is directly below the launching point of the sandbag. So it's the point where the sandbag will hit the ground. Firstly, we can see this is a right angle triangle because it is being vertically dropped and the ground is of course horizontal. We assume that in every question. So we can use trigonometric laws here. So we can say that because this angle 30 remains unchanged, this distance and this distance are related using the tan formula. So tan theta, in this case 30 degrees, is going to be equal to the opposite, which is the distance between the sandbag and the ground, which we will label as S meters over here. So the opposite, S, divided by the adjacent, which the distance between the shadow and the point where the sandbag will hit the ground, which is, we label it as small x. So x. So tan 30 is equal to S by x, and we know tan 30 is 1 by root 3. That's the same thing there, and therefore x is going to be root 3 times S. So that's the formula we found. And now the rate in meters per second of the shadow traveling along the ground is simply going to be the rate of change of this distance as we discussed, right? Which means that is derivative of the distance. So we need to find dx by dt. That's what we are supposed to solve for. And how do we get dx by dt from this equation here? We can take the derivative of this equation on both sides with respect to t. So we can use implicit differentiation over the chain rule. They both do the same thing here. So dx by dt is going to be equal to root 3 times ds by dt here. This is what we get. Now we need to find what ds by dt is at a height of 24 meters. And this is the rate of change of this height. That's what ds by dt is. There's one thing that we can do to solve ds by dt. We are given the equation of s of t. So if we take the derivative of s of t, we'll get ds by dt, right? So we can take s dash of t, which is the same thing as ds by dt. That's going to be the first thing over here. 60 will get cancelled out because it is a constant, so it'll become 0 when we take the derivative. And over here, the minus 4.9 t squared, take the power, bring it down and multiply, and then subtract 1 from the power. So it'll be minus 9.8 t. That is s dash of t. Now, so if you want ds by dt at the height of 24 meters, what value do we get from s of t? We need the t value at the height of 24 meters. So substitute into this, then we can substitute here to get dx by dt. So S of t is 60 minus 4.9 t squared. So that will be 24 because that is the height over here. That's the position of the sandbag. So 60 minus 4.9 t squared. So that means we can say that t squared is going to be 24 minus 60 by minus 4.9, which ends up being 36 by 4.9. And therefore t is going to be, when we take the square root of that fraction, 6 by the square root of 4.9, which is approximately 2.71 in a decimal. And now we have the value of t, which you need to substitute here. So s dash of 2.71 is going to be equal to minus 9.8 times this value. So we'll get minus 26.56 meters per second. And now we can substitute this value into here to get the final answer, the final answer of dx by dt. So dx by dt is going to be equal to root 3 times minus 26.56, which is going to be equal to minus 46.008 dot dot dot. And you may think that this is the final answer, right? No, that's not, because if you look at the question, it says round your answer to 2 places, which you have to remember, and this 2 places means 2 places after the decimal point. So we can see that that's 2 places over here, and the third one is greater than or equal to 5. So we add 1 to the second decimal place, and this approximates to minus 46.01 meters per second to be our final answer.